Greetings, one of the RC Wall Vacuum channel. Today's video I'm going to be diving back into the do-it-yourself wireless SCADA system for these fifth scale engines. I'm going to be working on the Kraken over there initially, but eventually I'll probably put it on this one. So let's take a look where that stands. So I got the receiver and transmitter board layouts done, got some blank boards in here now, and I'll concentrate on putting them together today, and then I'm going to give it a test fit too. At least that's the plan. Also, part of the plan is I'm going to do this project in stages. So today's stage, I'm going to take and put the transmitter board together and load the Kraken up, take it up on the track and give it a run. And I'm not going to put the receiver board together today. And what I'm going to do instead is I got these two breadboard setups here. One's got this little OLED display in here, and one's got an LCD touchscreen. And it's going to set the transmitter will send. I don't have any encryption on there, so the transmitter will send out data, and both these radios will pick it up. And I want to compare the two units, so I'll put these in the cab of the Ranger with a camera on them and monitor them while I'm out running. And they both have SD cards. This one here's got a little SD card here holder set up, and this one's got it on the LCD. But I don't have the SD software in there just yet. But that will be a future upgrade. It will get the SD recording. But for now, I'm going to just put the camera on there, and the other issue is I'm only going to do for today the cylinder head temperature and the exhaust gas temperature, and in future stages I will put on the RPM in there and also the LiPo voltages. So I have switched to some surface mount components on these boards, some of the capacitors and diodes and stuff in there, and I'll go over that in a few minutes. But that's the unique thing about these surface mount, actually a lot of unique things. The first one is size. Right there is a ceramic chip capacitor that's a 0.1 microfarad 25 volt through-hole device. In this tape there is 100 of a 0.1 microfarad 35 volt surface mount component, and that's a little 1 millimeter drill there, and it's pointing towards a little pocket where there's a little tiny part in there, and these holes along here that the drill's laying on are actually the pinholes for the feed on the pick-and-place machine. But it gives you the difference in size from going to through-hole to surface mount. Now, not all components have that radical of a change, but these ceramic capacitors definitely do. And if, like this 0.1 microfarad through-hole, like I said, it's 25 volt, these are 35 volts. So if this was to go up to 35 volt, they'd have to increase a little bit in package size as well. So how they fit all that stuff in there and make it work, I have no idea. So today's first attempt is going to be to get the board soldered up, and I'm going to be doing it under a microscope. I'll put a little video up of doing some of the surface mount stuff. I'm not going to be soldering those on there. I got these by mistake, and the board layout actually is for an 0603. These are an 0201, I believe. The numbers mean 0.02 of an inch and by 0.01 of an inch, which is a pretty small little package. So even though I won't be putting that small component on, I am going to be putting some pretty small components down. At the very end of that tweezers right there is a Schottky dial that's going to be put on there. And for size comparison, there's a 2032 coin cell. So let's head over to the microscope. I'll get the camera set up on there, and hopefully I can get some video of soldering on some of these components for anybody who's actually interested to see how that gets done. So there's several ways of soldering these components on here. What I'm doing is I just use a little flux pen, slap a little flux on there, and then I use this large hoof print type or hoof pattern tip, and I come in and just dab a little bit of solder on the iron itself, and then come in and drop it right on the pad, just a little tiny spot. Then reposition everything. Unfortunately, the camera and the eyepieces of the magnifier don't exactly line up, so it makes it a little tough trying to film this. But I'll just grab it. Ooh! And that happens from time to time too, and you gotta go search out for a new one. So we'll try this again. And I just set the component down on there and bring the soldering iron down on it and seal it up. Could have been a little better aligned, but and I'll spin it around and get the other side. Oh, and actually the little part didn't get too far. It ended up over here on the board. Didn't have to go get a new one. So we'll get this spun around. Get the soldering iron cleaned up a little bit and reload it. And then come in and still give it a little bit of support. Try to minimize the amount of heat you put into it, but you got to put some in there. Yeah, that seems pretty secure. So the first part I'm going to put in is going to be that Schottky diode I just showed. That's going in to give a reverse polarity, so if I put the battery in backwards, it doesn't smoke the electronics. The downside of putting the diode in there to do that task is the fact that there's a forward voltage drop. So I use the Schottky diode because it only dropped about 0.2 of a volt versus a generic silicon diode, which is pushing 0.7 of a volt. So if you're starting off with a battery that's only got 7.2 volts and losing 0.6 or 0.7 of those volts is kind of critical. So dropping it, so that's the reason it's going this style of diode. So like any diode, it's got its polarity. Has to be in there correct. So for some reason they put the 2 on the anode and a red spot on the cathode. I would kind of thought that would have been the other way around, but according to data sheet, this is supposed to be correct. So I got the diode in there now. Show you the relatively small diode drop that this thing has. 0.213. So if you're familiar with diodes, a silicon diode would be certainly about 0.665. I don't have the diode or the data sheet on this diode up here, but I believe that's a 1 amp diode. So I won't bore you with all the extra soldering, but I'll go through and finish putting the service mount components on, and I got a bunch of through-hole stuff to get in there. And then the next stage, I'll bring it back when putting it into the vehicle. So the board's all soldered up now, and gave it a little bench test. So the next thing I'll head it over to the vehicle. So over at the vehicle, I just got this little 3D printed box. I'm leaving it as an open chassis now. I'm developing this setup. But all it does is drop down in here. Kind of sits up there. It goes right. I'm going to set it right back into power it right off the light pole back in here. When I originally built this box, I had set so I could get two batteries in there. So the top one's going to be plugged right directly into this circuit, and then obviously the bottom one's going to be the vehicle. So I did have to cut another slot in the back there, but let me finish wiring this all in, and then we'll head up to the track. So we're up here at the track now. I have the 2 batteries stuffed in. The top one is actually powering the circuit, and the bottom one's the light bulb for the vehicle and the receiver and all the servos and all that stuff. And here it is up on top, the wireless transmitters up here on top with the thermocouples tied into it. And all tied back. And we're going to get the camera moved over to the receiver on the screens. And we'll get this thing fired up and see how long it lasts. There's 4 areas I want to watch for trouble. One, of course, is the antenna staying on there. I can't Loctite it on there because that interferes with the ground plane on the threads. So I can't have that back off. Obviously, they're not going to communicate, but it also risks the chance of blowing up the transmitter because it all of a sudden loses that impedance it's dumping current into. When I get this thing finalized, I'll have a 2-part box that'll come in, and the 2 pieces will come in with V's and pinch the nut in place, and that'll hold that. Another area is where I might be a little concerned about the spark plug coming loose with that CHT sensor underneath there. See how that goes. Let's see, another one too is these thermocouple connectors in here. I don't know how well those screws are going to hold those thermocouple wires down in there, but we'll see. And the other issue I'm concerned about is ignition induction pickup coming into the CHT sensor into those thermocouple wires. I don't think that would be a problem, only because that should be a common mode noise, and these thermocouple amps have a instrumentation amplifier, which is a two-part with a differential amp and a gain stage. And the differential amp's only going to look for any difference between the two lines. So if it comes in a common mode noise, it should reject that and just deal with what's coming in off the actual thermocouple. But we'll see how that goes. I don't expect to have a lot of success with this first time out, but we'll see how it goes. See if we can get some readings off it. Ready to fire it up. All right, we got lights. Give her a go. Oh yeah, she's coming up already. Well, hello there. I have to interrupt this broadcast because turns out at this point in the run video, unbeknownst to me, the antenna had broken off because some idiot decided to wire tie it to the bumper to save it from falling off, and the crash snapped that thing right off there. But what's interesting is as this video goes on, you're going to see the numbers still were coming in. They started getting erratic at points, especially as the vehicle was traveling farther away, like maybe 100 yards beyond where the receiver was. They get a little garbled, but they were still coming in, which I was pretty impressed with. So anyhow, back to the feature. Oh, still getting numbers. Still getting numbers. Get the hell out of the way with all this stuff. Ooh. So it's now sat for about 10 minutes, and the ambient's probably 85 or thereabouts right now. And as you can see, the cylinder and the head definitely hold their heat a little bit longer than the that thin metal exhaust pipe. Plus, that pipe's got ability for air to come up through it, I would imagine, to some extent. I'm still getting scrolly numbers somewhat down there on that bottom one. So two of the concerns I had were valid, and it also answers why I'm seeing some weird numbers. The antenna broke off at one point down there. It must be one of those, that one nosedive. So right now it's actually transmitting off with no antenna, which kind of surprised me that the transmitters keep working without an antenna. That's such an impedance mismatch, but it goes to show you how good those radios are. And the other issue is the spark plug is loosening up a little bit in there. Not sure how I'm going to keep that in there. So needless to say, I'm pretty impressed with these radios that this thing can work without an antenna. This goes to show you how good the radios are. They're supposed to be good for at least 5 miles with an antenna. They're looking at a couple hundred yards up here would have been the range it would have been running at. But all in all, I'm pretty happy with how this went. I got more stuff to do on it. Obviously, I secure the antenna better. And that was probably from that one nosedive into one of the dirt piles. I got to hook up the RPM sensor next and give that a go and see if we can get the three signals coming to this thing and do a couple of little fix-ups on it and be ready to go. So like I said, there will be a follow-up video on this, probably several. And I have an interesting twist coming up on the random ramp I built before. It's going to have a new way of controlling it. But anyhow, that's a couple of the videos coming up. So, but in the meantime, thanks for watching.